Hello and welcome back. So in this video what I want to do is cover some of the ways that scientists will view bones using CAT scans, MRIs, bone scans, and x-rays. Then I want to focus on x-rays and kind of review the bones that you've studied in previous tutorials and lectures, and then look at some bone injuries, and then finally finish up with some bone diseases. Alright, so a CAT scan is basically a computer controlled three-dimensional x-ray that is taken of your body, and it gives you great resolution and being able to see features of the body, soft tissues, hard tissues, and such. And then MRIs are basically is a scanner that exploits magnetic properties of your tissues. This particular scanner sends radio waves through your body and detects differences in the way that the body responds to these radio waves. And it also sees soft tissues, hard tissues, and is really good at detecting certain kinds of diseases. In a bone scan, scientists will inject a radionucleotide, a radioactive particle in your body. And this particular particle will oftentimes go or incorporate in areas where you have things like tumors that are actively dividing, so that we can get a kind of a resolution of where tumors may be growing in your bones. And then, of course, normal x-rays are using photographic film and then basically sending x-rays through the body, and in places where the body is hard or dense, x-rays don't go too well through those, but in places that are softer, x-rays will go through, and this will go to the photographic film and expose certain areas of your body to the photographic film. So in this diagram, let me go ahead and review a little bit of the normal bones. So of course we have the humerus and the scapula, we have the clavicle. These are various ribs here and here, and we can see the cervical vertebrae. Okay, so we want to go ahead and practice. You've learned all the bones of the body and many of the bone parts, and we want to use these normal x-rays in order to be able to practice some of those particular parts. In this particular drawing, you can see an outline of the lung. Lungs typically are soft tissues, and all of this should be relatively clear and black. In this particular person, there is some material in there, maybe indicating perhaps pneumonia or something of that nature. So they should be clear. Alright, so let's go ahead and we'll move on to the skull. So you know that the cranium is made of frontal bones and parietal bones and the occipital bones. In this particular picture, you can see pretty well the mandible and the maxilla. You can see teeth being anchored in. In this particular x-ray, you can see cervical vertebrae. You can see the spinous process back here in the back. And you can see the transverse process on the sides right here. These are transverse processes. And then the bodies of the vertebrae can be seen right here where these little arrowheads are. We can see spaces inside of the bones, the sinuses, so you can see various sinuses here and here. So these are some of the features you can see in this particular normal x-ray. Alright, so in this x-ray we're basically looking at seeing the different sinuses. So here's a sinus here and here. Frontal sinus, maxillary sinus, ethmoidal sinus, sphenoidal sinus. So those you can see in this particular image. Also, what I like to see in this image are the teeth. This particular person still has wisdom teeth that haven't erupted out. You can see the roots of the teeth in the mandible, anchored in the mandible, and the roots of the tooth anchored in the maxilla. We also can see cervical vertebrae here and here. And of course you can see the frontal bone right in here. Alright, so kind of looking at the abdomen of the body, we can see the lumbar vertebrae. So these are lumbar vertebrae. We can see the coxal bones pretty easily there. This would be where the sacrum will be located. So some of the, and then here's the femur, the head of the femur. Actually, that's the neck of the femur. There's the head of the femur there. We can see some of the different parts of the coxal bone, you can see the obturator foramen here and here, the pubic symphysis. So here's the pubis and the ischium, and of course the ilium, iliac crest up here above. All right, and so that's some of the parts of the coxal bones that we can see, and we can see here the little piece of the greater trochanter here and here, and of course head of the femur, neck of the femur. Okay, so those are some of the parts you can see in this X-ray. At any time, you can pause the video where there's no arrows on it and practice identifying some of the parts that you can see. All right, so here we have a hand, and this happens to be the left hand. And we'll just go over some of the bones that we can see. So we have going at the most distal area of the body, we have, of course, the phalanges. We have the distal phalanx, the middle phalanx, and the proximal phalanx. We have over here the metacarpals, making up the palm of the hand. Then here we have the carpals. You know, I won't go through each of the different carpals there, but remember we do have a mnemonic, time to come home, so leave there pronto. So it's kind of hard to see each one of these carpals there, but time to come home, trapezium, trapezoid, capitate, hamate, so leave there pronto, scaphoid, lunate, triquetrum, pisiform I really can't see here, but it's back there on the back surface. We also can see that in line with the thumb, we would have the radius, and in line with the pinky, we would have the ulna. So those are your two arm bones you can see there. Here, now you practice. Alright, so here we have the picture of the arm. So we have the humerus, and we have the radius, and we have the ulna. A few of the parts that you can see would include the olecranon process, head of the radius. I guess those are obvious parts you can see in this particular drawing. This is the back surface of the humerus. We can see the olecranon process. Let's see if I get a different color here. You can see the olecranon process here, the humerus, of course the ulna and the radius. Radius being here. And there's the head of the radius right there. We can see in the side view over here the head of the radius, olecranon process of the ulna, so ulna, radius, and humerus. Alright, so from a backside view we have the patella, and then we can also see the femur, and the tibia, and the fibula. You can see a couple of the parts if you look real carefully. You can see the condyles of the femur, condyles of the tibia. And then we have a kind of a side view of the foot over here, the lower leg. We have the tibia, and we have the calcaneus, we have the talus, and we can see a metatarsal up here. These bones down here are going to be your tarsals, and then of course down here will be your metatarsals. Okay, what bones do you recognize? Do you see the patella and the femur and the tibia and the fibula? You probably did. Okay, so here we have the foot. And down here we have, of course, the big toe, and then big toe right here. This would be the distal phalanx and the proximal phalanx. We have the distal phalanx, middle phalanx, and proximal phalanx. Each of these are metatarsals. And then we have the tarsals down here. So here we can see the phalanges, metatarsals, and then your tarsals. Calcaneus is obvious, the heel is obvious, and then we have the tibia, which is pretty obvious right there. All right, so what I want to do is now is kind of review bones, but also show you some x-rays of damage. So here we have a cracked frontal bone. So we have the frontal bone, parietal bone, occipital bone, and these would be bones that you could see pretty easily. We have the vertebrae back here, cervical vertebrae that you can see as well. But that's a little hairline fracture of the frontal bone. Just something odd I came across when looking through the internet. This would be a nail that was shot through a person's head. Nail gun accidents are pretty common because nail guns are pretty common. But again, you can see the frontal bone up here, parietal bone, occipital bone, and you can see the cervical vertebrae here and here. You can see the spinous process here and here, and then the body of the vertebrae there. We can see the mandible and the maxilla with the teeth embedded in it. Just another nail gun accident. This was a spear gun accident that happens as well. That's a 3-inch fishing spear that went through a person's cranium. So quite amazing. This is a CAT scan showing kind of like a crushed skull. I thought it was kind of interesting. You can see some of the temporal bone here crushed into pieces, and we can see parts of the frontal bone damaged and parietal bone. Here we can see the occipital bone back up in here, and then cervical vertebrae. So from a frontal view, you can see the frontal bone. It's been quite damaged. Of course, we can see the nasal bone here. A little piece of the lateral bone right there and right there. And then we can see a zygomatic bone right there and there. Mandible. This is tooth decay. I thought that was kind of interesting. You want to make sure you brush your teeth every day and floss so that we don't get tooth decay. So this is what happens when bacterial infection gets in and begins to eat your teeth. They have tried to put a cap over top the tooth and a filling right here, but they'll have to go in and really kind of dig that stuff out. These are normal teeth on the right-hand side. You see the enamel up here. Here would be like the pulp cavity down there, and here would be kind of going down here would be your root of your tooth. Anchored in the bone. And remember, this is a gomphosis, or I guess you won't remember that until you watch the joint lecture, but this is a gomphosis, and this is basically a type of joint where you have a ligament called the periodontal ligament that holds the tooth into the actual bone. Alright, so here we have a broken collarbone or clavicle. So here we have two parts of the clavicle. Looks like it's even separated too. Just to kind of refresh your memory on bones, we have the humerus and we have the scapula. Of course, we have ribs here and here and here. Okay, and then we have cervical vertebrae here and here and here. Thoracic vertebrae would be located here. They're not really well pictured, but your thoracic vertebrae will be located in there. And this is how we put it back together. We put a plate in there and put some screws in. So here is the plate right here, and with the screws anchoring in the plate so that the bone can heal correctly. Alright, so this appears to be a fracture of the ulna and radius. And you can see the ulna and the radius, and here's where the fractures are located. This looks like a green stick fracture. Maybe the force of trauma happened there and the bones are kind of not so strong and they kind of fractured out the other side. And we may have a young person dealing with a young person right here. It seems like I see a little bit of an epiphyseal growth plate there, but a very small one. Up here we have carpals, and then metacarpals, and then phalanges would be further up. Here we have a crushed fracture, a comminuted fracture, where the bone has been broken into parts. We can recognize the ulna here and the radius with each of the little parts. And then we have carpals over here. Metacarpals look like they've been crushed. And then we have phalanges up here. These are phalanges. Obvious feature is the olecranon process, and we can see the humerus additionally. This looks like a fracture of the humerus right here, so you can see kind of the medullary cavity, which is kind of cool, head of the humerus. And perhaps this is a spiral fracture. It looks kind of in the spiral area, but I don't have any information on the fracture, but it does look like a spiral fracture. And then you can see the radius down here and the ulna in this X-ray. Here we have a shoulder replacement. So we've taken the head of the humor and we've taken it out, and we have taken out probably a little piece of the scapula, and we've been inserted in now a new head of the humerus. We can see ribs. These would be true ribs up here. We can see a clavicle. And again, this was the humerus. Alright, so on the left side of this drawing, on this x-ray, excuse me, we have the femur, and it's been broken into several different pieces. To put that back together, we take a plate, put the plate in, and then we take screws and put the pieces back together. We can see the head of the femur. We can see the acetabulum of the coxal bone, which is kind of cool. I just thought this image was interesting because there were just screws in the tibia. So this is the tibia right here, femur, patella, and fibula. There's a screw going through. It's kind of interesting. This is a total knee replacement where we've taken the head of the femur and the top portion of the tibia. We've grinded those things out and then put this insert in to replace that. Notice that they did leave the patella intact. So we have the quadriceps tendon and patellar ligament holding that patella in place. And we can see the fibula and the tibia, pretty obvious features. What's interesting about this particular picture is that the patella is absent. There is no patella there. So you can see the femur up here, and you can see the tibia and the fibula, but there's no patella. Also kind of interesting about this is that you can see the epiphyseal growth plate here and here. So this person was young, or is young. Was young, I guess. It would be a better way of putting that. So there's that epiphyseal growth plate. So you can look at an x-ray and determine the age of a person by looking for the epiphyseal growth plate. Here is a total hip replacement. We've taken and ground out and put in a cup for the acetabulum. We've ground away and removed the head and neck of the femur, and then put an insert in there. You can see the bone screws going into the coxal bone. And then over here we have a normal femoral head and a normal acetabulum. A couple of the parts you can see would be the obturator foramen, the pubis, ischium, ilium. Sacrum would be located in this region right here. And then lumbar vertebrae would be up in here. Just another picture of a total hip replacement. It just seems like in this particular image right here, it just looks like that screw would hit some abdominal organ, but I guess it didn't. You can see the pubic symphysis. That's separating the two coxal bones. So that's a little pad of fiber cartilage separating two coxal bones from each other. Alright, so in this image here we have a dislocated foot. So here we have the tibia and the talus, and we have a disarticulation between the two of them. You can see pretty obviously the calcaneus, and then we have other tarsals. Okay, so you can see the tibia and the fibula, and then your tarsal bones. We can see metatarsals as well right here. These are all metatarsal bones. Okay, I just kind of was interested at the screws through the bones, so you can put screws in to hold parts together and reconnect them together. And so just to refresh the bones of the foot, we have the phalanges, metatarsals, tarsals. Okay, so you can see those pretty easily right there. Of course, these would be the cuneiform, and then the cuboid, navicular. And then I can't see, it's kind of washed out, but talus would be located right in that region there. And this is a bunion, just a little extra bone growth that sometimes occurs in people. So here we have a broken metatarsal. It's broken right here, almost through the center of it. Broken metatarsal. High heels put unnecessary strain on the metatarsal phalangeal joint. So it's not really good to wear high heels where you put unusual pressure on these particular things. You can see this in the X-ray. I'm an animal lover, so I thought it was kind of cool. This dog had eaten this little plastic toy, and you can see it in an X-ray. You can see its ribs and its vertebrae, lumbar vertebrae, thoracic vertebrae, which is kind of neat. And down here, this was a key found. I guess somebody swallowed a key, and you can see an X-ray of the key inside of the intestines there. But you can see the sacrum and the lumbar vertebrae. This is a compression fracture of, it appears to be a lumbar vertebrae. So the lumbar vertebrae are really sensitive to compression fractures because that's where all the weight of your body's held. So here you can see the vertebrae has just been compressed and collapsed. That's a problem for your nerves because your nerves will come out in between your vertebrae. So you don't want to get the body of the vertebrae collapsed and crushed so that it will impinge on a nerve. So a couple of diseases associated with the skeletal system include scoliosis. Scoliosis is kind of like an abnormal curvature of the spine. Here you can see the spine is curving where it should be in a straight line. They have put in this particular image here, they have put in a rod to try to pull that spine back into a more normal arrangement. So we want to pull that spine back in this way. Scoliosis can be a problem because if you let the bone curvature get really bad, it starts to impinge on organs, and your body will literally collapse. So you'll lose height, and your body will literally get to compress on itself and compress organs. So we want to get that spine straight if possible. Another bone disease is a vitamin D deficiency known as rickets. So in rickets we get a curvature of the bones, as you can see in these diagrams of these unfortunate children here. You can see that their bones are curved, leaving the legs kind of like bow-legged. Because the bones are soft, we don't get a hardening of the bone, so it leaves them soft and flexible. So that disease is called rickets. It's a vitamin D deficiency. So this is an X-ray showing polydactyly. So sometimes you can be born with extra bones. So you can see these digits here: 1, 2, 3. 4, 5. Let's see if I can do that again. See if I can count them. So we have, let me go back here, get my arrow. 1, 2, 3, 4, 5, 6, 7. 7 digits. Although these digits look like they're still under the same skin, it would look like one digit. So that's called polydactyly. And where they're attached, it's called syndactyly. I'll show you a picture of that. So this is syndactyly here. This is where the skin holds the two bones together. Okay, that's called syndactyly. We have here polydactyly, so there's an extra digit there. This is an unusual formation of the bones of the foot. It's called clubfoot, and this is what it looks like under an x-ray. And a pretty big problem, because we have an aging population in the United States, would be arthritis. And you can see arthritis from the outside. This is where you have inflammation and swelling and damage of the joints in this rheumatoid arthritis. And here's what the joint looks like when you look at it under the x-ray. This is a lot of times an autoimmune disease where your body begins to attack the joints and causing that swelling to occur. Lastly, we'll finish up with some osteosarcomas. These are bone tumors. So you can see the tumor just growing outside of the normal confines of the bone. Here's an x-ray of a bone tumor, so you can see what that looks like. And this osteosarcoma has really grown significantly large outside of the bone. You can see the medullary cavity right here. And unfortunately, it appears this bone cancer may have occurred in a younger individual, because I can see the epiphyseal plate, which is the growth plate. Okay, well, that finishes up this little small lecture on looking at x-rays and reviewing bones and some bone diseases. So I'll see you in the next video.